Hi dears, welcome to Brilliant Katha JEE Mantra Series Chemistry Part Test 5 Recap video. In this video, we are mainly going to discuss, revise the important topics from the chapter, some basic concepts of chemistry, classification of elements and structure of atom. For JEE examination, these three topics are very important. You can attend minimum of 3 questions from this all 3 chapters. And also, integer type question also can come from the chapter, some basic. So that's why these chapters, especially the structure of atom, classification of elements, the periodic table and all is very important. So it's the time to check, it's the time to revise all 3 chapters. Are you ready? So let's start with the chapters. Here we are going to discuss about some basic concepts of chemistry, structure of atom and classification of elements. So let's look about the important concepts of the chapter, some basic concepts, okay. So here, these are the important concepts. First one, we have to discuss about the laws of chemical combination during chemical reactions. They are actually following a lot of laws, okay. They are actually following a lot of laws like law of conservation of mass, law of definite proportion, law of multiple proportion, law of reciprocal proportion, Gay-Lussac's law of gaseous combining volume, Avogadro's law. These all laws, they are actually following that laws. About that laws, we must have to go through. Okay. Then again, mole concept. What is mole idea? What is number of moles, that mass relation, number of moles, that volume relation. All idea we have to go through it. And then molecular formula and empirical formula idea. Then limiting reagent during a reaction. What is limiting reagent? What is excess reagent? That idea. Then concentration of solution. The reactions in solution, that time we must have to know about the concentration expressing methods like molarity, molality, normality, mass percentage, volume percentage, mole fraction. Like that ideas we must have to know. These are the important ideas from the chapter, some basic concepts. Okay. Yeah. Next, once we are looking on this chapter, you can see the first idea is laws of chemical combination. In that first idea is what? Law of conservation of mass. We know the idea. During a chemical reaction, total mass of reactant should be equal to total mass of products. That is what is actually what? Law of conservation of mass. To conserve the mass only, we always balance the chemical equation. That idea we know. Ready? Yeah. Next, we have to look about law of definite proportion. It states that law of definite proportion or else law of constant proportion states that if a compound is formed from any source, anyway, if a compound is forming, the elements present in in a compound, the elements present in the compounds, okay, compound is fixed. They are actually combining with a simple whole number ratio of their fixed masses, okay. Their masses are fixed. For example, if we are looking about carbon dioxide is forming, carbon dioxide we can prepare in different way. Either we can prepare carbon and oxygen. If we are combining, we will get carbon dioxide. Okay, we will get carbon dioxide. Or else if I am treating methane plus oxygen, combustion reaction of hydrocarbon, that will also will give you what? Carbon dioxide you will get. Whatever the way you are getting carbon dioxide always contain 2 elements, carbon and oxygen, and their masses are in the ratio. Carbon's mass is 12 and oxygen mass is what? 32. So their ratio is 12:32. Their mass ratio will be fixed. Okay, that is what is called a constant proportion. That idea, you know. So if they are discussing about only one compound, means law of definite proportion. And what about law of multiple proportion? This states that when 2 elements combines to form more than one compound, mass of one element is fixed, masses of varying elements are in a simple whole number ratio. For example, carbon and oxygen, they are forming more than one compound, like carbon monoxide, carbon dioxide. Okay. Then here, what about the ratio of their masses? 12:16 as well as 12:32. So here you can see the mass of carbon is fixed. Okay, along with that, the combining oxygen's ratio is 16:32, 1:2. This is a simple whole number ratio. That is what is law of multiple proportion. So if they are talking about what? When 2 elements combines to form more than one compound, that time. More than one compound, if they're talking, means that is what? Multiple proportion. That basic ideas, you know. Anyhow, I am simply revising it. Okay. Next, you have to go through the remaining laws and all. Then we have to look about what? The very important idea, that is what is mole concept. One mole means what? That's actually Avogadro number. That means 6.022 into 10 to the power 23. That may be particle, maybe atoms, ions, electrons, proton, neutron, whatever. 6.022 into 10 to the power 23. Numbers if you are taking, that is what is called 1 mole. That means for an element that is 1 gram atom, not 1 gram atom, that is different. 1 gram silver atom is different. 1 gram atom silver is different. 1 gram atom comes together, that is what is mole. Okay, 1 mole of an element, that's the meaning. Or else in the case of compound, 1 gram mole of a compound, and if you are discussing about its volume, it should be 22.4 liter at STP or NTP. This is actually mole concept. That related question should be there. Okay, it is a mandatory area you have to focus. You must have to go through. This is the basic idea behind it. By using that only, we usually used to solve a lot of questions. That one number of moles is equal to number of moles is equal to that idea. We must have to remember number of moles is equal to given mass by atomic mass GAM into given mass by GAM. This many moles are there in the case of what? Atoms. In the case of molecules. In the case of molecules, I mean elements, it should be given mass by GMM into Na means we will get exact number of molecules. If you want to find out the number of moles of atoms, okay, number of moles of atoms or number of moles of molecule means no need to multiply with Na. That idea, you know, that formula you have to go through. And if they are giving the volume means you have to calculate like what? Given volume by molar volume. So given volume, they will give in the question, molar volume means 1 mole's volume, that is 22.4 liter. Once you are dividing, that time also you will get number of moles. That relations, that equations, you must have to go through it. Okay, yeah, ready. Next, we have to look about what is empirical formula. Empirical formula is the simplest atomic ratio of different elements or different atoms present in a compound. That is what is called the empirical formula. And molecular formula means which gives the exact number of atoms present in a compound. That represent what? Molecular formula. For example, benzene. Benzene, you know, benzene's molecular formula is C6H6. C6H6. We know the idea. And that represent exactly in benzene 6 carbon is there, 6 hydrogen is there. That's the idea. Ready? Yeah. But benzene's, this is actually molecular formula. But benzene's empirical formula means the simplest ratio of atoms. That means carbon 6, hydrogen 6 means the ratio is C1H1. This is what is empirical formula. So that idea you have to remember. Then one more idea you have to remember. Empirical formula mass. Empirical formula mass into scaling factor. Okay, scaling factor is equal to molecular formula mass. That idea you have to remember. So whenever you are multiplying with this n value, how you are getting molecular formula mass divided by empirical formula mass, that time you are getting n value. Like that you can calculate empirical formula, molecular formula related questions. You can do it. You have to go through it. Okay, you can easily solve it. Okay, yeah. So this is the idea about where the empirical formula as well as molecular formula. Next one, the very important idea is limiting reagent. Whenever they are giving a stoichiometry related problems, calculation, that times we must have to check whenever they are giving the reactants amounts, I mean different amounts of reactants if they are giving means that entire reactants need not to be reacted. Some reactant may be fully reacted, some reactant may be excess. The reactant which consume completely in a chemical reaction, or else the reactant which limits the entire reaction, which stop the entire reaction after it is completely consuming. That is what is called a limiting reagent. With respect to limiting reagent only, we can tell how much amount of product is forming. That idea we must have to learn. Okay, yeah. Next idea we have to look about the concentration of solution. Concentration expressing methods like molarity. Molarity is equal to number of moles divided by volume of solution in liter. That only we are using WB by MB into 1000 divided by VML. WB means given mass of solute, MB means molar mass of solute, VML means volume of solution in milliliter. That idea we know. Then molality means given mass of solute divided by molar mass of solute. This is MB, capital letter MB, okay, into 1000 divided by WA in gram means given mass of solvent in gram. And mole fraction of any component means that its number of moles divided by total number of moles. So here number of moles of solute divided by total number of solution. That means number of moles of solute plus number of moles of solvent. That is what is a binary solution. Okay, for binary solution we are using like that. You learned about volume percentage, mass percentage. That all are important. All you have to go through it. I mean, instead of learning a lot of theory, you just go through the questions and you just practice maximum question. Then if you are not getting means come to the theory. These some basic concepts and all. Easily you can crack it, guys. Easily you can crack it. Okay, ready? So the next topic we have to focus is actually structure of atom. in structure of atom, a lot of important concepts, theories, as well as the problem related questions may come. So here, once you are going through that one, the important areas are cathode discharge tube experiment, cathode ray discharge tube experiment done by J.J. Thomson to discover what? That electron discovery and all, subatomic particle discovery and all. Then alpha particle scattering experiment to explain about, Rutherford did this experiment to explain about what? The nucleus idea. Then E by M ratio related question, charge by mass ratio, that is specific charge related questions usually used to come. Then electromagnetic waves. For you people, you already learned electromagnetic waves related chapter already there in physics also. So here, but a small topic we have, there we must have to know about which all are the electromagnetic waves, cosmic ray, gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio, that rays we must have to know, and their what? Frequency, wavelength, order. I mean, from cathode ray to, whenever we are going from cosmic ray to the radio wave, what will happen to frequency, what will happen to wavelength, that idea, okay, that interconversion, then nu equal to C by lambda, that simple ideas we must have to know, from there questions may come, okay. Then photoelectric effect also you are learning in physics actually, but here we have to learn some basic ideas related to what? What is photoelectric effect, what's the equation for photoelectric effect, that and all ideas, okay. So next, Bohr atom model, that's very important for us. Bohr atom model, that's actually developed from hydrogen spectrum, that idea we must have to focus through. Then de Broglie dual nature concept, okay. Not only particle nature, wave nature also there, that wave nature we can calculate by using the formula lambda equal to h by m with that idea. Okay, then after that, Heisenberg uncertainty principle, that also very important. Then quantum mechanical model of atoms, and finally the electron fillings in atomic orbital. During that time, they are actually following some rules like Aufbau principle, then Hund's rule, Pauli's exclusion principle. That much idea we have to go through, means then we can tell that our chapter structure of atom also we can finish like that. Okay, see, anyhow, in structure of atom we can look one by one very important ideas here. First idea, we are directly going with what? Hydrogen spectrum. You have to go through you have to read, you have to go through the basic idea. What is that cathode ray discharge tube experiment? What is alpha particle experiment? Okay, alpha particle scattering experiment, that you have to go through it. Okay, yeah. So here we are directly going with the hydrogen spectrum, in especially hydrogen emission spectrum. And if the electron is jumping from anywhere to n equal to 1, that is what is Lyman series. We know the idea, Lyman series. Okay, anywhere to it is coming to n equal to 1. Okay, Lyman series. Then anywhere to n equal to 2 it is coming, means that is Balmer series, Paschen series. Okay, Balmer series. Anywhere to n equal to 3 if it is coming, means then that is Lyman-Balmer Paschen series. And anywhere to n equal to 4 it is coming, means bracket series. Anywhere to n equal to 5 it is coming, means Fund series. Anywhere to n equal to 6 it is coming, means Humphrey series. That much idea we know. So any lane in this hydrogen spectrum we can calculate by using Rydberg's formula. Anyhow, this Lyman series, that lanes in Lyman series actually belongs to ultraviolet region, and Balmer series is the one and only visible spectrum. That's actually colorful one, visible region they are laying. And the Paschen series, bracket series, Fund series, Humphrey series, all series lies in which area? That lies in infrared region. Okay, and once we are looking about any lane in hydrogen spectrum, we can calculate by using the formula, Rydberg's formula, nu bar equal to 1 by lambda into 109,677 into 1 by n1 square minus 1 by n2 square. That n1 is the final state. And n2 is the initial state. Okay, initial state. And if the electron is moving towards 1, if the final state is 1, then that is Lyman series. If the final state is 2, then that is Balmer series. If it is 5, that is Fund series. That's the idea. And if the electron is coming from n equal to infinity to n equal to 1, n equal to infinity to n equal to 1. Okay, so this is actually n2, this is n1. So final electron is coming to the 1, means that is Lyman series. And if it is coming from infinity, means then it is called a limiting lane. So limiting lane of Lyman series means infinity to 1. Limiting lane of Balmer series means infinity to 2. Limiting lane of Paschen series means infinity to 3. Like that. From infinity to that particular series. Okay, that is what is the limiting lane. First lane, another time you have to remember from here, it is first lane. First lane means that's very important idea. First line means always from where to where it is coming. In the case of Lyman series, just about to first one. So that is what is, so n equal to 2 to n equal to 1 if the electron is shifting. That is the first line of Lyman series. And passion means what? Passion means what's the series passion? Passion means n equal to 3 it should have to come. So that means from 4 to 3 it is coming. That is first line of what? Passion series. Bracket series means 5 to 4 it should have to come. Like that, the first line, okay. So that idea you have to remember. And the first line should be always, first line means that should be having low wavelength. Okay, the thing is that the energy is less. Energy is less means their frequency also less. That means what? Wavelength is more. So first line means always the longest wave. And here once we are looking about the limiting line will be having the shortest wave because its energy will be more, frequency will be more, so wavelength should be less. That much idea you have to remember. And then one more formula you have to remember about what? Bohr's model of atom, Bohr's model of hydrogen spectrum. Okay. During that, the radius of nth orbit is equal to, what's the formula? Rn is equal to 0.529 into n square by z angstrom. Okay, and energy of nth orbit is equal to, this formula also how to use, energy is equal to minus 13.6 into z square by n square electron volt per atom. That much idea, that series, that idea you have to remember. Then again, you can find out the number of spectral line. If the electron is jumping from n2 to n1, then the total number of what? Spectral lanes, they can ask like what? Sigma n2 minus n1, that formula. Suppose if the electron is jumping from n equal to 5 to n equal to 2, how many spectral lanes are possible? You can simply put that value here. From 5 to 2 means 5 minus 2. 5 minus 2 means sigma of 3. Sigma of 3 means 1 plus 2 plus 3. Up to 3 you have to add continuously the numbers. You have to add it. 1 plus 2, 3. 3 plus 3, 6. Total 6 lanes are possible. Like that idea you need. Ready? Yeah. Next again, once we are looking about this chapter, de Broglie concept, not only the particle nature, they can exhibit wave nature also. That wave nature you can calculate by using the formula lambda equal to h by p. P means momentum. Instead of momentum, I can write mv, mass into velocity, or else I can write in terms of kinetic energy, h by root 2 me. E means kinetic energy. Okay, kinetic energy. This kinetic energy is nothing. That's equal to, kinetic energy is equal to q, charge into potential difference. Okay, voltage, charge into voltage, like that also I can write. That only we wrote. So that related problems can come, may come. That idea you have to remember. Okay, ready. Next again, Heisenberg uncertainty principle. According to Heisenberg, it is impossible to determine simultaneously both the position and momentum of moving microscopic particle like electron with accuracy. Accurately, we cannot find out the position and momentum simultaneously for microscopic particle. That is what is called Heisenberg uncertainty principle. Its mathematical representation is delta x into delta p greater than or equal to h by 4 pi, or else delta E into delta T. Energy change into uncertainty in energy, uncertainty in time. That will be greater than or equal to h by 4 pi. That also we can use. Instead of this delta x into delta p, we can use like this also. Delta x into m delta v greater than or equal to h by 4 pi. Like that also we can utilize. We can use that formula also. You have to keep it in mind. Then finally, the last important idea is quantum numbers. Quantum numbers means they are actually the address of an electron. There are four quantum numbers are there. Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. The first three quantum numbers, which are the principal quantum number, azimuthal quantum number, and magnetic quantum number. These three are the solutions of that Schrodinger wave equation. And the fourth quantum number, that is spin quantum number, is experimentally determined quantum number. That idea you have to keep it in mind. What about principal quantum number? It gives the details about the shell in which our electron is present. Its possible value is n 1, 2, 3, 4, etc. N equal to 1 means K shell, n equal to 2 means L shell, n equal to 3 means M shell, like that. Okay, I know that you guys know the idea, even though I am simply revising it. Okay, you have to keep it in mind. Once you are going through this video means you can go and check the questions. If you are not getting means you can come back to theory again, like that. Okay, ready? Yeah. See. And second one is azimuthal quantum number, or else it is also called a subsidiary quantum number, or else it is also called what? Angular momentum quantum number. angular momentum content number. Okay, angular momentum content number. That idea you have to keep it in mind. What? It gives the details about the shell, or else it gives the details about the shape of the subshell, or else it gives the details about what? Angular momentum. So its possible value is 0 to n minus 1, and if it is L equal to 0 means S subshell, L equal to 1 means P subshell, L equal to 2 means D subshell, L equal to 3 means what? F subshell, and we can calculate angular momentum of any subshell by using the formula root of L into L plus 1 into H by 2 pi. Instead of this H by 2 pi, I can use the term H cut. Okay, H cut or H head, that is H by 2 pi. So that formula also I can use. That idea you have to keep it in mind. And the third quantum number is, third address is actually magnetic quantum number that represent orientation of orbital in space. Its possible value is minus L to plus L, including 0. Okay, that idea you have to keep it in mind. Then after that, we have to look about spin quantum number. It's the experimentally determined quantum number. It gives the details about the spin of electron around its own axis. It may be either plus 1 by 2 or minus 1 by 2. Clockwise plus 1 by 2, anti-clockwise minus 1 by 2. Okay, and finally, last here, one more thing you have to remember: the nodes and nodal plane. Okay, nodes and nodal planes. Nodes means it is the region around the nucleus where the probability of finding electron is minimum, 0% to 5% electron probability. I mean, very less electron probability. Finding electron probability is very less, means that is what is called nodes. If we are considering nodes in a plane, that is what is called planar nodes. Okay, that is actually nodal planes. In a region, in a plane, electrons are not present. That is what is called nodal planes. There are mainly two types of nodes are there. First one is radial node, or else it is called what? Spherical node. Radial node or else spherical node. The number of radial node or spherical node we can calculate by using the formula n minus L minus 1. N is the principal quantum number, L is the azimuthal quantum number, and or else number of angular node is equal to angular node, or else it is called, its shape should be planar node equal to L. So what's the total number of nodes? These two I have to add. So n minus L minus 1 plus L means n minus 1. For example, if they are asking about 5D subshell, okay, 5D subshell, how many angular nodes are there? Angular nodes means I can directly write L value. L value for D is how much? L value for S is 0, L value for P is 1, L value for D is 2. So L2, 2 angular nodes should be there. How many spherical nodes or radial nodes should be there? Its N value is 5, L value is 2. So N minus L minus 1. 5 minus 2 minus 1. So total 2 radial nodes will be there. This is the idea. Okay. Yeah. Next again we have to look about the rules for filling electrons in orbital. The first one is Hofbauer principle. Hofbauer is not a scientist. Okay. Hofbauer is not a scientist. It means set builder. Actually, that gives the idea about details about what? Filling of electrons in orbital taking place in the increasing order of their energy. Or else by using the same technique only, we are telling in terms of N plus L theorem. N plus L theorem telling like that, whenever the electron filling taking place in the increasing order of their N plus L value, if two orbitals have same N plus L value, lower N value will be filled first. For example, 4D and 5F is there. Which one is going to fill first? How we can find out? It's N plus L value. N value is 4, L value is 2, N plus L is 6. And here N value is 5. Okay, L value is what? N value is 5, L value is 3. So total N plus L value is how much? 7. So in the increasing order of N plus L value only they will fill. So 4D will fill first, then 5F will fill. That's the idea. Okay. The next one is Pauli's exclusion principle. It states that maximum an orbital can accommodate 2 electrons. That means no 2 electrons in an atom can have same address, same quantum numbers. Okay. 2 electrons cannot have same address. That is what is Pauli's exclusion principle. And that's why from that idea we will get in one orbital maximum 2 electron only can accommodate. If there is one more third electron also there, means the first and third electron will have same spin quantum number. That is not possible. Okay, and the final one, Hund's rule for maximum multiplicity means the pairing of electrons in degenerate orbitals like P, or px, py, pz, or else dxy, dxz, dyz, dx square minus y square. I mean, in the case of D subshell, Pairing will take place only after they are singly occupied. That is what is called Hund's rule of maximum multiplicity. That related questions also, they usually used to give diagrammatic electronic configuration. They will give, then they will ask which one of the following is wrong. Like that question they are asking. So you should be prepared. You should be ready to answer at whatever the extent. If they are asking question, you should be ready to answer it. Dears, okay, we will be there. I will be there along with you to crack all the question from that chemistry, all the question from they are asking for JEE and all. Okay, we will be there. Okay. So next we have to look about classification of elements and periodic properties. The important concepts in this chapter is actually idea about modern periodic table. Okay, where exactly if they are giving an element, okay, atomic number is 73, where exactly it belongs, what's the group, what's the period, that kind of idea we must have to know. Okay, then periodic properties like atomic radius, ionization enthalpy, electron gain enthalpy. Okay, especially this ionization enthalpy and electron gain enthalpy is very important, very important. Okay, then electronegativity, electropositivity and valency, how these properties are varying along a group, along a period as well as along a group, how it is varying. That also we have to focus. That also very important. And first of all, we are looking about atomic radius. Atomic radius means it is the distance from nucleus to, outermost shell containing electron. That is what is called atomic radius. That can be expressed in terms of van der Waals radius, or in terms of metallic radius, or in terms of covalent radius. For non-metal, covalent radius. For metals, metallic radius. For noble gas, van der Waals radius. Always van der Waals radius will be greater than the metallic radius than the covalent radius. Okay, that idea you know, and how it is varying generally from moving from left to right. I mean, along a group, along a period, once we are going from left to right, atomic size is decreasing because of the increase in effective nuclear charge. Similarly, I mean, but at the last, I mean, compared to halogens, if you are comparing fluorine as well as after fluorine, which one will come? Neon will come, halogen will come. Compared to fluorine, neon's atomic size will be more, because fluorine's atomic size we usually used to tell in terms of covalent radius, but neon's atomic size we usually used to tell in terms of what? Van der Waals radius. That kind of ideas you have to remember. Then whenever we are going from top to bottom, atomic size is increasing because of the increasing number of shells. But there is one problem is there. In F block elements you learned what? That lanthanoid contraction, that idea also you have to keep it in mind. Zirconium and osmium have similar radius. Okay, that idea you have to keep it in mind. Then again, next about ionization enthalpy, it is the amount of heat energy required to remove an electron from an isolated gaseous atom. That its unit is kilojoule per mole. Always we have to give the energy to remove an electron. So that's why it is always endothermic, and the variation along a group, ionization enthalpy is generally decreases while we are going down, because the atom become more bigger. So automatically we can easily remove the electron. And while we are going from along a period, ionization enthalpy is increases generally increases, but boron's ionization enthalpy is less than that of beryllium, as well as oxygen's ionization enthalpy is less than that of nitrogen, because of their electronic configuration and shielding effect idea that you have to go through it. That's very important. Then next one, electron gain enthalpy. Electron gain enthalpy means actually it represents the enthalpy change, heat energy change, when an electron is added to an isolated gaseous atom. Majority atom, whenever we are adding one electron to that atom, majority atom will always release energy to get that electron. Okay, but some atoms, so that's why we can tell majority atom it is exothermic in nature. First electron addition exothermic, but second, but again in some atoms like what? Magnesium, calcium, noble gas, nitrogen, phosphorus, etc. In their case, they are already having stable configuration, because magnesium, calcium, etc. S2 configuration, noble gas is already completely filled configuration, nitrogen, phosphorus, P3 configuration comes, means half filled configuration comes, means they are highly stable. So to adding electron, one more electron will be difficult. That's why their delta HEG value is less negative or positive value. So that is difficult to add. Difficult to add means that is positive value, that is endothermic in nature. But even though the first electron addition only we are having doubt whether it is exothermic or endothermic, but whenever we are adding second electron or third electron or fourth electron, always that should be positive. Very difficult to add the second or third or fourth electron, because there should be an electron repulsion will be there. That idea also you have to go through it. And next again, electronegativity. It is the ability to take, ability to withdraw the shared pair of electron towards any atom. That is what is called electronegativity. Along a group, electronegativity decreases. Along a period, electronegativity increases up to halogen. The highest electronegative atom in the periodic table is fluorine. That was given by the idea. Pauling scale is there. That idea you know. If you know the electronegativity, from that we can find out the percentage of ionic character by using the formula 16 into chi A minus chi B. Chi A and chi B are electronegativity of atom A, atom B. Okay, that 16 into chi A minus chi B plus 3.5 into chi A minus chi B all square. That formula we can use means we can find out the percentage of ionic character. If you are getting a value x means then the percentage of covalent character is 100 minus x. Like that you can do. So like that so many wide varieties of idea you already went through. That ideas you have to recollect it, and anyhow you just go and do maximum number of questions, maximum varieties of questions. Okay, we already did a lot of questions. Anyhow, if you are having time means you have to go through with a lot of questions from all these chapters. Then automatically whenever you are not getting means come back to theory. That should be our way of approach. Okay, yeah, no need to waste time to learn theory again. Instead of that, do the problem, and whenever you are having doubt, come back to theory like that. Okay, yeah. So do your best, dears. Do your best in the next examination. See you in the next video. Thank you so much.